relevant CV there. I'm basically been a BIM champion, and I'm now an information management champion. And I'm with a consultancy called Deploy, which is a information management consultancy for the built environment. And we help both clients and members of professional teams to use digital processes. So the agenda for today is basically 2 quick points and then 1 long one. What is information management? Why did it emerge from BIM? And how do you use it to deliver the desired outcomes of all projects? So, first of all, what is it? Essentially, it's a process. It's not a product. It's not particular software. It's a process. And it's based on structured, shared information. By structured, we mean that all the information. Yeah, somebody's got their mic on. Kelly, thank you. It's based on structured information, which means that everything is filed in a proper labeling manner so the machines and the people can read it. And we have the concept of information containers. A container is anything that contains information. So it's a drawing, it's a schedule, it's a report, it's a photograph, it's anything that contains information. It's shared. The information is never privately held by individual team members, except when they are working up their own contribution and before they have shared it with others. But the project's official information is on a common data environment. So people do not have the wrong version of it. And then what is information? It's everything about what, why, where, when, how, and who of the entire project setup. And we have an international standard now that defines it, which is ISO 19650, which is first published at the end of 2018, but guidance has been developed over the last 3 years now by a lot of volunteers who've populated a thing called the UK BIM framework. So why is it important? Basically, projects have been continuously plagued with errors, omissions, ambiguities, inaccuracies, lack of coordination, all of which are due to poor information handling. And analog information, that is the stuff you draw and write, which is not held or converted into digital, is notoriously prone to these errors. The result of that is that people make decisions slowly because they're not quite sure, or they make them quickly and then repent. And clients changing their mind because they finally realize what the thing is really like that they're going to get. That's one of the main reasons why we have delay and claims on contracts. Levels of trust in our industry are, as you know, low. And one of the reasons for that was lack of trust in the information. People know that they're tendering on inadequate information, so they cover themselves with contingencies and they act defensively, avoiding collaborating fully. So the whole idea of managed information is that it gets over a lot of those problems, and we can have much higher levels of collaboration in the team and much more rapid working. So BIM, which we've had for 10 years or more now, has had a great impact on those who've used it. It's enabled us to survey sites by scanning, which is cheaper and faster and less risky than conventional surveying. It's enabled better coordination of design. It's enabled stakeholders to understand things far better. And the accurate visualization that it produces quickly is very useful for the planners. It's also terrifically useful for constructors. It helps them to use off-site construction and also to set things out and to check progress. I'll just expand a little on each of those. Design coordination. This was the low-hanging fruit, which first attracted consultants and contractors. The idea that you could stop people's information from stop people using the same piece of space for a pipe and a beam, or stop them from producing a component which doesn't then fit when it arrives on site. This is relatively simple to do and a huge payback and a reduction in risk. Everybody's contributions are kept separate whilst they're developing them, and then they are federated by the lead consultant so that they all fit together. And that, when we're at the specialist contracting stage, the contractor does this as part of design management, and it takes out a huge chunk of risk. The other major improvement is that stakeholder engagement can move from people who can't read drawings to people who can share virtual reality with each other and actually see pictures and discuss them either on a headset or in what's known as a BIM cave, which is what this illustration shows, where you can actually look together at a design which may or may not need sorting out, and then have it develop in front of you very often so that you can solve the problem if that's what you see, or fully understand what it is you're going to get. Better decisions made quicker and more sticky, more final is the aim of the game, and that has clearly happened in the use of BIM. The planners have also benefited greatly. Three-dimensional applications. Some cities have models of themselves already, as the City of London does, so that any application can be dropped into the city's model, and you can then see how it fits and see what issues it raises in context, including things like wind or traffic impacts. And you can also make changes in response to comments fairly quickly using a BIM program. And when it gets to contracting, modern methods of construction essentially require you to have a digitally based design. You can do all sorts of things. You can set out the project. You can instruct robots to help you build it, like this one, which is a device that climbs up the structural lift shaft and does all the drilling that's required. It's a dangerous job, and there are thousands of holes to make, and you want them done precisely, and you can have them done 24 hours of the day if you want. But even more importantly, you can improve safety. And you can also check that the work has been done that you expected to have done during any particular day. At the end of the day, you can have a report produced overnight which says the work was or was not done that you planned to do today, and it was or was not according to the drawings and schedules that you had. This particularly advanced method of tracking is called Spot, the robot dog, and he has a scanner on his back, and he goes around after work checking everything and produces a report which is available before work starts the following day that says what was really achieved and whether it was okay. This is artificial intelligence as well as scanning technology. But BIM is not enough. Building information modeling, which is what BIM stands for, really has only caught the attention of designers and design managers in construction. It was seen as very design focused and geometry led, although it wasn't, but that's the way people played it. Clients were not engaged sufficiently, nor were asset and facility managers. And some of the other disciplines in the design team have been very slow to see the point. Just to give you an example of why designers loved it, you can actually recreate lost buildings. And here's an example of a building, Frank Lloyd Wright's Larkin building in Buffalo, of which we have the drawings, and therefore we can make a model. So it had that powerful attraction to designers, but not to a lot of other people. Information management is defined as much broader. And although we're going to go on using the term BIM because it's locked into a lot of our guidance systems now, what we are calling it is better information management, not building information modeling. So this migration, first of all, we had CAD, which came in really mostly during the 1980s. To produce two-dimensional drawings, but the machine did not actually understand what it was drawing. It simply made lines on whatever it was you were going to print it out on. Then we got 3D modeling, which was the beginning of understanding of what these lines meant and that they were objects. And objects have characteristics and can be labeled and tagged. And it was described as BIM from about 2003 in the USA, 2008 in the UK. And we defined it officially by British Standards Institute producing what was called a publicly available specification. PAS 1192 came out in 2012, and the government adopted a whole series of procedures, which then enabled them to announce that 5 years from then, in 2016, there would be a mandate that government projects would use BIM. And that gradually had its effect. But other countries saw what we'd done, and there was a great deal of enthusiasm to turn this into an international standard. So PAS 1192 went back into the works and reappeared as ISO 19650. And that came out, as I said, from the end of 2018, and gradually it's been developing a number of parts, which we'll come back to. But the UK is basically the source of this, and the UK is definitely in the world lead in organising information management as an official industry process. The whole thing was backed up by evolution in the RIBA plan of work to support information management. There are obviously decisions made at the end of each stage, and those decisions have been tweaked to and listed in the plan of work, so that the broad categories of decision that you should be making at the end of each stage are there to follow. And of course, there may be several interim stages within each stage and several iterations within each stage at which decisions will be taken to move you towards the end of the stage. Plus, there is now a stage 7, which is when the building is put to use. And that's a very important addition to the RIBA plan of work. Now, one of the major weaknesses of old style practice was that people made their design decisions quite late in the day, quite far into stages 3 and 4. They started to make decisions that they had put off from earlier on, or they weren't in the position to take, or they revised things as the implications became clear. And very much at the beginning of the BIM process in the United States, the chairman of HOK, who are probably the original champions of BIM, came up with this idea that if we could only move our decisions forward and make the key decisions during stages 2 and 3 rather than in 3 and 4, we would actually spend a lot less on those changes, and we would get a lot more value out of them, because we would not have got into massive documentation and detail. We would not be going back again on ourselves. This was called the McClamey curve, and it's in American terms. This description. But if you look at the stages in question as 1, 2, and 3 to the left, and then 4 in the middle, which is where the specialist contractors come in to do at least part of the detailed design. The McClamey curve is really quite an important insight, that the later you leave a change, the more expensive it is and the less useful it is. So policy decisions need to be made early, and they can do that with better information management. So the ISO 19650 project started off with a general principles document, which is part 1, a capital projects part 2, which explains the process, and that's the one we're going to be principally talking about. Part 3 is to cover the management of information in assets in use, facility management and asset management. Part 4, which is about to appear, covers the exchange of data between the capital project period and the asset in use. Part 5 already exists and is about security-minded use of information management. Security is a big issue, not very often addressed satisfactorily. And part 6, which is also due probably this year, covers the use of information management in health and safety and the whole business of the golden thread, and all the things that came out of the Grenfell disaster. Now, there is you always have to pay for standards, and they're quite expensive, but you can almost manage without them, because the guidance, which is free, is on a website called UK BIM Framework, and is really comprehensive. And you almost need guidance to the guidance because it is so deep. And some of that is what I make a living out of doing, is guidance to the guidance. But essentially, there are those 4 active parts of ISO 19650 underneath the principal one at the top. And then there are detailed guidances across the bottom, which you can see to key parts of the whole procedure, including things like the common data environment and the protocol, which we will mention further into this talk. Now, one of the googlies about PAS 1192 is the language it uses. ISO 19650. PAS 1192 was written in English for the British using their terminology for the industry. That turned out to be full of the usual English language ambiguities and crossovers. It didn't translate well because the ISO standard is available in several languages. And the writers of it decided to do what Humpty Dumpty said, which is, a word shall mean what I choose it to mean, no more and no less, which they decided that they would have new words for almost everything. And I think they basically got that solution right, but they didn't do it perfectly, as I will explain. Humpty Dumpty, by the way, is a character in Alice in Wonderland, for those of you who haven't read it. So, clients in the 1192 world are called appointing parties, or APs. Anybody they appoint directly is called a lead appointed party. And that's typically the lead consultant and the main contractor. And then any sub-consultants or specialists are called appointed parties. But of course, this didn't really take account of the fact that clients tend to appoint all of their consultants across the board directly. They're not usually appointed through the lead consultant. And that confuses the language a lot. And I prefer that the term lead appointed party be limited to the lead consultant and the contractor, with all others as task appointed parties, or TAPs, which we will go a little further into that in a moment. But it means that project teams are really teams of teams, which of course is no surprise. The consultant and the contractor team have leaders, and all the professions have tasks. So they are task teams in this language. The lead consultant would probably have a task as well, and therefore they're also a task appointed party. Now, this is a chart I don't expect you to read, but I'm going to show you blow-ups of it in a minute. But it essentially shows you that the three columns of activities. The left-hand greeny blue is the client's column, the appointing party, all the things they have to do to set up the project in the first place, and then take the key decisions as the project proceeds. In the middle column, we have the lead appointed party, whether that's a consultant or a contractor or a transfer from one to the other. And that's what they do to feed the client with what they need to have, but also to draw on all the material produced by the task appointed parties, who are the pink column on the right. Now, the initial client activities, now there's a whole lot of these, and most clients are surprised to find how much they're asked to do at stages 0 and 1 before they're really in a position to instruct their team. They can work their way through these either by getting client advisors on board before they start the job proper, or by choosing their lead consultant on a non-contractual basis to start with, and work up the detail so that the scope of each appointment is quite clear before they try to make it. One of the big difficulties with information management has been people trying to start using it in midstream when they're already well into the project, and then finding that their scope changes and the client is very reluctant to change the deal that's been struck. So we do need to understand these front-end activities. One of them is what's called client information requirements, which is a whole series of processes. What do the clients need to support their decisions during the process? These are known as organizational information requirements. What do they need at the end of the job when they've got the asset? What information do they need from that, which is called the asset information requirement? And those two together form the project information requirements, and are all part, along with a lot of other things, of the exchange information requirements, or EIR, which is the whole package of stuff that describe the scope of service of all of the members of the team. Client is also expected to set quite a number of rules. The standards to be applied, the production methods and procedures, the naming and numbering conventions, and also to compile all the site and other relevant information for the project team. The naming conventions are vital to the digital information management process, and they're set out in the standard and its supporting guidance, so it's not something you have to invent. This example is an empty lot beside Chelsea Creek in West London, currently used as a police car pound, but there's a planning application in for it. All of the planning application information, including a site survey, needs to be preloaded into the common data environment in order to start the team off running. Now, the common data environment is another absolutely fundamental brick in the wall of information management. This is a server, either held by the client or by the lead consultant, or rented from a service provider as a cloud facility. And essentially, it's to provide everybody on the team with a single source of truth. The common data environments that are provided online have to deliver a series of rules so that the work done by individual firms, which is private to them, work in progress, top right-hand corner, is accepted for sharing by the lead consultant and then shared with the rest of the team, federated, corrected, and then passed to the client for approval. As it goes through these gates, its status as information changes and it becomes usable and is updated as soon as the client has accepted the movement through the gates. And it becomes an archive for audit trailing right through. The information protocol is an idea which is, again, strange to clients and often ignored, but not good practice to do so. Essentially, your instructions in the use of information management to the team are, that is the client's instructions, need to be attached to the contract, and they need to contain all of the rights and responsibilities of the parties in using information and in sharing the use of information, plus any security requirements. And this is a document which needs to have the force of law, so it needs to be attached to the contract. And JCT has provided a way of doing that in a supplement called BIM and JCT Contracts, which is available from JCT and prompts you to think about the various clauses in the contract which refer to information management, and helps you to populate the protocol so that you get a legally attached set of instructions. So when you've got all those, once you've compiled the exchange information requirements and the reference information, all that's loaded into the common data environment with the tender response requirements, and then the invitation is sent out. This process applies equally to appointing the consultants as it does to appointing the contractors if you're using a form of procurement which involves 2 stages. And the competing teams respond to the invitation to tender by processing the instructions that they've received and working together to produce what's called a BIM execution plan, which has an answer to each of the points in the exchange information requirements and enables the team to then bid for the job with all of its qualifications required. And the client can then complete the appointment by negotiating the final information plans for each player, defining what they are with the lead consultant or contractor. And ideally, fees shouldn't be final until the client's instructions are final. But that's what happens at the point where everybody knows exactly what they're expected to do. And then there's an additional stage, mobilization, which, because we're working in a technological environment, means everybody needs to know that it works for them. They need to set up their technology. They need to test it all. They need to have their people suitably trained if necessary, and they need to understand the methods and procedures so that they're all ready to roll before kickoff. All of their risks need to be understood as well, so that nobody is going to be surprised by anything. Then the project simply proceeds through a series of repeating stages and intermediate stages so that information is prepared for the client as required and then submitted, and the client either doesn't accept it, in which case it loops back, or does accept it, in which case the decision point is passed, and everything in the CDE then updates to the new state, and on we go until we finish. And at the end, the stage 6 material of the project model becomes the asset model, the as-built version, with all the product information provided and the golden thread for future facility and asset management. The data can be automatically transferred into computer-aided facility management systems, provided the information has been organized with that in mind. Equally, lessons learned should be set down to improve the next project process. Well, now we move on to helping clients, and because clients very often are not ready for all this, and sometimes they're not even suitable clients. So pre-qualifying the client, are they a client who is a regular user of the industry? Do they retain and manage the facilities that are created by this? This list on the left tells you the sort of organizations that are likely to be that sort of client. If so, this whole process is very much suited to them. For others, a more edited, limited version will probably suffice. But to set a client up in an information management way, you really need to have a consultancy that takes the client through the various preparatory steps and gets them all set up so that they can actually operate at the level that they're capable of doing. And when one doesn't get a long prior setting up phase in a live project, ideally. Now, I'm just digressing at this point to talk about the sort of thing that this is, because it's essentially about briefing. Briefing conventionally, and this is a diagram from an American approach known as problem seeking, tries to organize the information that the client needs by saying, what are the functions, what are the formal factors, what's the timing, what's the economy, and then moving from the client's overall goals through what are all the relevant facts, through to what are the policies we're going to apply, and then finally, what are the specific needs that we're going to ask for the design to demonstrate if it's going to be accepted. Now, that model can be turned into a brief for information. Again, don't attempt to read this in detail. If you want to study it later, then ask me for the slide. But this shows you where the various clauses in that process flow diagram actually apply. You move from the goals for information, which are in the first column, through the facts and how they're going to be used, to the policies that are going to be applied, and finally the actual needs that spit out as to how we're going to operate the information management approach. And the final outcome of a project of this sort is that we get a facility which is not just a built thing, but is also a virtual thing. There is a model of the building alongside the physical building, which can be used to support facility management and asset management. And you can apply software solutions to link the asset model to a lot of other things that the client is likely to be using during the life cycle of the building, from his business enterprise software through individual projects that he might have, geographical information that might flow, the building management system that is continuously producing data, and for which breakdowns can be anticipated by looking at that data. And facility management and repair information is in the asset model, so that's how they serve each other. All this is moving towards the concept of the digital twin. That's something which information management is leading towards. It's not a mainstream thing yet, but it is beginning to appear. Commercial buildings in particular have dived into becoming smart, as they call it, smart buildings. These are ones which are loaded up with sensors and analytics to enable them to manage the use of space and the performance of M&E systems, and provide concierge type services to occupants. But in the case of many of these smart buildings, they haven't got a model. They don't actually see the connection. So they are only limited in their concept of having a digital twin. But the Hickman in on Whitechapel Road is one of the first commercial buildings to actually have a proper digital twin, where the model of the design is linked to the sensors so that performance can be monitored through the model. You can look at the performance of fans and pumps. You can look at the spatial occupation pattern. You can plan and allocate space to people who want to use it. And you can supply concierge services to the occupiers. It's an increasing area of practice, and it's a natural outgrowth of information management. Now, the public sector has been given its marching orders by a publication from 2020 called the Construction Playbook, which is basically saying how the government recommends that public bodies buy buildings and organise teams and conduct themselves as clients. It's very fulsome. There are 14 areas of detailed instruction, but one of them is that you will use information management to ISO 19650 as the fundamental way in which you instruct and gather back the information that you need. There's a new component of this. The Construction Playbook is actually in review at the moment for being updated, and that review will include the use of what's called the Value Toolkit, which was released just this month and is a way of understanding what it is you need for a building in a much more fulsome way, other than purely economic factors. It takes into account environmental and social factors as well, and the human factors in employing people and in occupying the building. A very interesting thing to look through. But anyway, it's all masses more information, and it all has to be managed. One of the other things in the Construction Playbook is the recommendation that teams should be stable, not just employer client to consultancies or to contractors, but specialist contractors and specialist consultants working together as often as possible. And that collaboration is ideally based on framework agreements where teams work together or they have the prospect of working together when they compete to join a team. But they all teach each other, they learn from each other. The model form of contract for that is FAC1, which Professor David Mosey developed and is published under that term. And the government commercial arm has picked that up and said, right, this is the one we're going to use. David is also working on a new form of contract called the Integrated Information Management Contract, which tries to bring information management in as a foundation to the form of contract. So that will be a very interesting development. These things are not just public sector either. Note this last week that Mace has signed a multi-project framework agreement with Night Dragon to build about £2 billion worth of buildings on the Greenwich Peninsula. So conclusions are that basically information management to ISO 19650 is the basis of digital working from now on. Information management unlocks modern methods of planning, design, construction and operation, providing the golden thread for lifetime efficiency and safety in the building. And the published guidance on the UK BIM framework is comprehensive, excellent and free. So I recommend that you dive in and have a look at that, and you could have a CPD session on every single part of it, but only if you're intending to specialize like I am. So that concludes the presentation for today. I'm open to taking any questions that you like. I'm also able to provide you with a PDF of these slides if you write to me at richard@deploy.co.uk. And so over to you, Tracy.
Okay, so has anybody got any questions that they would like to put to Richard? Very quiet. Oh, here we go.
Thanks, that Richard is really interesting. I was just remember when I was learning about BIM, it was all that PAS 1192 Part 2, and there was like big focus on like BIM maturity levels. I'm right in saying that they've all now, that's all superseded, or it's not really common, like recent current terminology to talk about BIM levels?
It certainly isn't, no. And particularly this idea of BIM level 2, which was regarded as the government goal in 2016, that was a package of requirements which you took as a package. And it was quite clear that clients had different levels of maturity. They either didn't want all that stuff, or they wanted a particular set of it. And the idea of BIM level 3, which was some mystical future level, well, nobody ever defined that, and it has just melted away and been replaced by this switch to information management. But that doesn't mean we don't have maturity issues. The level at which a client is able to play this game and the level at which team members are able to play the game depends on how mature they are in handling digital information in their organizations. So the issue of maturity still comes up, both for the client advisor in helping the client and informing the team by making sure that you're not appointing people who are out of their depth.
Okay, cool. No, that's really interesting. So it's less about like what sort of models you have and more about how well people manage information, as in like the stakeholders.
Yes, indeed.
Yeah. Cool, thank you.
Great, thank you. Does anybody else have any questions while Richard's here? Doesn't look like it.
There was another voice when Charlie was starting up, but anyway.
No, I think that's it.
Okay, well, if you do have any further questions, email me and I'll respond to that. But otherwise, thank you for your attendance, and I hope that's been of use to you in your careers.
It's great. Thank you so much, Richard. And do tune in, everybody, for the next event that pops up. And thank you again, Richard.